Hey everyone, today the topic which we are going to study is the shape of periodic table. Okay, so this is the topic from your chapter number 3, which is periodic table and periodicity of the properties. Now, in this topic, what we're going to study is actually that what is the shape of the periodic table and why is that so that we have in the first shell we have only two elements. In all the other shells, in all the other periods, we have more than two elements and each and everything. Okay, we will discuss what are periods, what are groups, and what is in general what is the shape of the periodic table. Okay, so first of all, as you know that the first shell has how many electrons? You know what is the electronic configuration of the first shell? Okay, first of all, the first shell is also known as K shell, so you should know the name. Okay, and the electronic configuration of the first shell is 1s2. Okay, if you haven't watched my previous video which was named as the electronic configuration, okay, so you can watch my that video as well, so that you can get the concepts of the electronic configuration, so that would be easier for you to understand this thing as well. Okay, so okay, let's get started. So the first shell has electronic configuration of the 1s2. It means that it would have in total how many electrons? It can accommodate the maximum 2 electrons. So it means that in the first shell, in the outermost shell, what we're gonna have, we can have only the 2 electrons, not more than the 2 electrons. Okay, so like you can see here, this is the first shell starting from the hydrogen and it ends at the helium. Okay, so it means that it can accommodate only the two elements, right? This period would have only two elements. So the hydrogen, as you know, the hydrogen has only one proton. Okay, or you can say the one electron, because electrons and protons are always same in number. Okay, so first of all, you can see here this is the first period, so hydrogen is in the first period. Okay, the period number shows. Okay, so first of all, I should tell you that what are the groups and periods. So these horizontal rows, they are known as periods, and these vertical columns are known as groups. Okay, the period number tells you that what is the number of the valence shell. Okay, or if you want to remember this, you can also memorize it by, it tells you the number of the shells the element would have. Okay, like the if the hydrogen is present in the first period, so it would tell you that hydrogen would have only one shell. The lithium is present in the second shell, so the lithium has only two shells, right? So as the number of the period increases, so it tells you that the element would have increasing number of the shells, right? So like you can see here, we have the sodium. So sodium is present in the third shell, so it would have total three number of shells. Okay, then the group number tells you that how many electrons the element would have in its outermost shell. Okay, so like the hydrogen, let's take the example of the hydrogen. So hydrogen is placed in the first group. Okay, so it means that, okay, first of all let us draw the shape, the shell. Okay, so as you know that it is present in the first group, the first period, as well as the first group as well, you know. So from the period number we have drawn the one shell, and now as it is present in the first group, so it would have only one electron in the outermost shell. So basically the concept that is given here is that in the first shell we have only two elements. Why? Because the first shell has this configuration 1s2. It means that it can accommodate up to maximum 2 electrons, so it would have the two elements. The second shell, as the configuration of the second shell, which is also known as what, the L shell. So what is the configuration of the second shell? It is 2s2 2p6. So how many electrons on the maximum it can attain, it can accommodate? It can accommodate up to 6 7 8 8 electrons. It means that it would have how many elements? So definitely the 8 elements. Similarly in the third shell, which is also known as the M shell. What is the electronic configuration of the M shell? It is 3s2 3p6. Okay, so we are doing it from here. Okay, so you can see that the okay, first of all let us discuss the second shell. So the second shell starts from this lithium. Okay, so the lithium has two electrons in its valence shell. Okay, sorry, one electron in its valence shell. Why? Because it is present in the first group. Okay, then as we move along the period, what would happen? The number of the outermost electrons would get increased. Okay, so it means that next in the list we have beryllium. Beryllium is present in the second group, so it would have two electrons in the outermost shell. Then we have the boron. It is present, as it is present in the third group, then this shows that the boron would have three electrons in the outermost shell. Okay, and similarly it goes on, and then this second shell, it ends at neon. So the neon would have the electronic configuration that is 2s2 2p6. Okay, so this is what is a 2s2 2p6. It means that this neon would have the maximum electrons the L shell can accommodate. Okay, that is why the L shell would end at the neon. As you know that it cannot accommodate more than 8 electrons, that is why the L shell would end at the neon. Okay, then we have the third shell. So the third shell starts from the sodium. Okay, now talking of the sodium. So sodium has how many shells? First of all, as it is present in the third shell, so it would have three shells. One, two, and this is the third shell. And how many electrons would it have in the outermost shell? So as it is present in the first group, that is why it would have only one electron in the outermost shell. Okay, which is also known as valence shell. And then okay, then as you know, the lithium was having the configuration of 2s1. Sodium has the configuration of 3s1. Okay, that is why the sodium is placed beneath the lithium. Okay, as you know, the shell number is increased, so the sodium is placed beneath it. Similarly, magnesium has the configuration of 3s2. So how you can get to know about this, that what is the configuration of any element? I've made also the separate video on this, so you can watch that video, but here I'm also revising it for you. Okay, that how we are gonna determine what is the electron configuration of any element is that first of all, how you got to know this and this number. So this number, which is a 3 or any number, it can be any number, so it depends upon the number of the shell or the number of the period in which it lies. Okay, for example, the sodium lies in the third period, that is why we have put a 3 in it. Okay, then the S number is 1. How we got to know this? As you know that the sodium is present in the group 1, so this basically tells you this number that is written above the S, P, D, F. These are all the subshells, right? So they show that how many electrons would the element have in the outermost shell. Okay, so that is why that is how we get to know the electronic configuration of any element which is present in the periodic table. Okay, so that was about the sodium, and I have told you about the magnesium. So can you tell me what would be the electronic configuration of magnesium? So let us see. It is present in the third period, so 3. Then S. Why S? Because it can have only 2, because it is present in the second group, right? So the 2 electrons can be accommodated by the S shell. Okay, and that comes first, that is why we write S first. Okay, so we would write 2. Why? Because it belongs to the second group. So this is the electronic configuration of the magnesium, and the beryllium would have the electronic configuration of the 2s2. Okay, that is why we place magnesium below the beryllium. I hope it is clear to you. Okay, then this third period, it ends at the argon. Okay, here is argon. It ends at the argon starting from the sodium, and here you can see it ends at argon. Okay, and this argon would have the electronic configuration of 3s to 3p6, which is the maximum configuration the M shell can attain. That is why it would end at this level. Okay, so now you got to know why the different periods they have different number of elements, and why they are starting from particular element and ends at the particular element. Okay, and now and as I've told you that all the elements that are arranged in this periodic table, they are in the order of increasing atomic number. Okay, so as we move along the periodic table, move along the period and move down the group, so you can see that the atomic number of the elements gets increased, right? And one very important point as well is that the elements that have the same electronic configuration, like told you before, that like hydrogen has 1s1, lithium has 2s1, sodium has 3s1. So all the elements that have the same electronic configuration, valence shell electronic configuration, okay, so they are going to be placed in the same group, right? So that was all about the shape of periodic table. I hope this is clear to you, and thank you.